Okay. Okay, the first thing that we studied today is the distance and the midpoint formula. This is easy. Let me explain in detail. Suppose that we have different points. I want to recall, but I know very well that you know very well the plotting the points. For example, you plot the point P1, que P1 is 6,4. Now you need to know that the first number represents the x component and the second component is y represents the second. You find on the x-axis 6, 4. Plot that. Boom. This is P1. P2, suppose, is minus 3, 4 again. Okay. The minus 3 is on the x-axis, but in the opposite direction, to the left and 4. 1, 2, 3, 4, minus 3, 4 is here, P2. Same y component, but it's in opposite direction. By the way, this region here, this region is the first quadrant. Okay, this region is, let me change another color, the second quadrant. So any point. Entonces the shortcut second quadrant to see that when the x is positive, y is positive. Okay, Professor, I am in the library, so my internet is a little bit. Okay, in the library, yeah, I know, in college. And what library? In Hunter Campus. Yeah, the Hunter Campus, Karen. The internet is no good, but okay, you try. Remember, this is the I recording, so you can watch it again, and you do know. Now, when the x is negative and y is positive, that is the perfect identification that the point P2 belongs to the second quadrant. Suppose another example, P3. P3 is, suppose, negative 3 again, but negative 5. Oh, both components are negative. In this case, it's a negative 3, negative 5. I suppose it's here. It's P3. When the 1 point lie in this region. To your job. It's because belong to the third quadrant. And one more point, P4. P4 is negative 3, no, negative 3, no. It's positive 4, comma, negative 4. Okay, positive 4, negative 4 is positive 4. The first component is x. Remember, it's agreement. You have to respect this. 4, negative 4 is here, P4. And when the one number lie in this region, let me use in blue color, belong to the fourth quadrant. Let me see, it's when the x is positive, but the y is negative. In this case, third quadrant is when the both are negative, less than 0. There are some special points. For example, P5 and P6. Okay, it's located exactly in the boundary of the quadrant, so it don't belong to any quadrant. It's on the x-axis or on the y-axis. For example, 0,7, 0,6, 0,6, 0,6 is here. 0,6 here. P5 belong to the any no quadrant. It's exactly on the x-axis. And for example, 4, 0, when the one component is 0, it's because it's on a specific axis. In this case here, 4, 0, P6. I suppose you remember very well this. Yes or no? No?
Yes.
Okay, cool. Now, my goal now is the distance formula. Distance formula and midpoint formula. Okay. Okay, I have another rectangular coordinate system. So what is the formula that we are using to determine the distance between 2 points? Suppose, hypothetically, P1 is here, P1. By the way, it's 2, 2, no? But it's okay, I don't care the value now. In another example, yes. And P2 is here, P2. Que es 5,5, no? Yeah. Entonces now my goal is determine the distance, get the length of this segment. Okay, no good. It's the length of this segment. 45 degree, I guess so. 45 degree because the component is the same, 2255. 45 degree. Look perfectly. Now we're connecting this point by the segment line. Okay, now my goal is determine the formula that we are using to this. Suppose hypothetically, that the component here is x1, y1, because belong to the point 1, no? And this is x2, y2, y2. Okay, to find that, we can interpretation, like for example, we have a triangle like that. Okay, and by the way, this triangle is right triangle, 90 degree, and we can apply, why not, the Pythagorean theorem. So to determine, for example, this segment is x2 minus x1, because this is x2, this is x1, so horizontally speaking, and this is y1, and this is y2. Okay, so this partial something is x2 minus x1, this segment, and this segment is y2 minus y1. And together are a triangle, it's a right triangle, we can apply Pythagorean theorem. So the distance d, distance d, and between P1 and P2 segment is the big square root of subtraction x2 minus x1 squared plus y2 minus y1 squared. Suppose you remember very well Pythagorean theorem. Pythagorean theorem is applied in the right triangle. This is ABC. And a squared gets the hypotenuse is equal to b squared plus c squared. Now you find this segment B, is this. You find this segment C is this. And you put in the formula. Of course, I want to find the hypotenuse, so now I erase this square and you put a square root here. It's the same idea. Cool? We practice. After I bring the problem to do. But this is the formula. The most important thing is the formula. Distance formula is the name of this formula. It's the distance between 2 points. Okay, and what about midpoint? Well, midpoint is easy. Midpoint is you have P1, P2 again, but we have one point in the middle here. P midpoint. This is a midpoint. Midpoint. Midpoint is the point in the middle, can be set in two equal parts. This segment. So it's easy because basically it's like an average. So you, for example, midpoint have two components, x sub m and y sub m. And what mean that? This is the component que characterize the midpoint es x sub m, y sub m. Entonces es x sub n is the average in between the x, is x2 plus x1 divided by 2. And the y sub n is y2. Either way, the order is not important because it's plus. Plus y1 divided by 2. And this is the coupled formula to determine midpoint. Any question? Sound easy, eh? Okay, so let's do it first. One elementary example. And after that, we're doing another more complicated. After the complicated, we are doing application of this. Okay? Application. But okay, one easy first. Example one is straightforward to understand very, very well the distance formula and midpoint. Okay, there you go. Again, we have another rectangular coordinate system. Of course, we can use in decimals, but in this case, I want to explain by hand. I don't know why I want to explain by hand. Suppose we have 2 points given. Suppose find the distance and midpoint as the goal of the in between the point P1 is negative 4, 0, and P2 is 4,6. Wow. Well, okay. Okay, important. First of all, step 1 is plot the point. So we need graphical part. You plot the point, negative 4,0 is here. Bam. Okay, this is P1. And you plot the second point, get 4,6. I suppose que here. P2. 4 and 6. Okay, cool. Now, my segment look like no 45 degree, no. It's something like that, approximately, yeah, approximately, 36 degree. It's not important the degree. Okay, boom. This is the segment. Yeah, I want to find the length of the segment. And also, why not, the midpoint. Wow, I predict the midpoint. This is the midpoint, M, midpoint. I predict that the midpoint would be 0,3, no? But I don't know. Let me try mathematically. So first of all, I put the formula. Distance, let me write this notation. Distance between P1, P2 segment is the square root. I copy the formula. X2 minus X1 square plus Y2 minus Y1 square. And who is Y2, X2, X1, Y1? This is X1, Y1, because belong to the point 1. This is X2 and Y2. But you feel free to subtraction the X component and the Y component separately and totally independent, what is the first, what is the second, because the only difference, so you change the order, is the size. But in the format, when you square, become positive. So the shortcut to do super fast, and you take, for example, you take in that part, you take the X component, and you subtract them. So what is the difference between the subtraction negative 4 and positive 4? So the majority of the students say, no, it's 0. No, it's not 0. It's not 0, it's this segment. Look. is this segment. Then between -4 and +4, it doesn't matter the direction. So you subtracting 4 minus 4, or minus 4 is -8. So basically it's 8 unit. So this, we have here 8 square. Okay, some more formal students say doing in a different way. Okay, x2 is 4, is this, and x1 is -4. There's a negative, double negative, no? Become positive, and 4 plus 4 is a squared is 64. Cool. A squared is 64. Plus, and the y component, well, similar. We are doing similar. You manipulate this and this inside this parenthesis. Okay, actually, the thing we're finding is that part. Okay. So basically is 6 minus 0 or 0 minus 6, que es just 6. 6 squared. So this is 64. This is 16. Together is, wait, it's 36. Hello, I'm crazy. 36. 6 times 6, 36. And together is 100, and the square root 110. This distance is 10. The red distance, that distance is 10. 10 units. What kind of unit? I don't know. Maybe it's centimeter, maybe it's feet, depending the unit of the graphic, depending the unit of this point. But it's linear unit, no square. It's no area, it's linear distance. Okay, this is the final answer. Then 10, 10, 10, 10, 10. Okay, what about midpoint? Midpoint is different. Midpoint is this formulas for midpoint is x sub m is x1 plus x2 divided by 2, and y sub m is y1 plus y2 divided by 2. The order is not important because it's addition. Addition is completely commutative, so we can switch in the component and the answer doesn't change. The subtraction, bueno, you can, but the problem is that you square. Okay, so now the component for the P1 is -4 is x1 plus +4 is x2 divided by 2. Wow, it's 0. It's 0 because 4 minus 4 is 0. 0 divided by 2 is 0. And this is logical. According to the symmetry of the figure, our midpoint I predict at the beginning is located at the point 0,3, no? Therefore, the x component is 0. Exactly, we get that. Bam. Now the y component, no, because you take the y, this guy and this guy, so it says 0 plus 6, or yeah, 0 plus 6 divided by 2. 0 plus 6 is 6 divided by 2 is 3. Wow, exactly the prediction that we are doing in the graphic part of the midpoint we get algebraically or arithmetically using the formulas. Any question? Do you understand very well or no?
Yes.
No? Okay. Okay, let me complicate a little bit because it's too easy, I suppose. So we have, yes, Emily said yes. Suppose that we have another, but in this case is another example case. No 2 point, it's 3 point. 3 point. Suppose that we have 3 point. Distance formula. Suppose that we have 3 point. The point is given in the example 2 is The point is called ABC. A, B, and C. 3 points. Each point have component. The first one is minus 2, comma 1. I plot that. Minus 2, comma, minus 2, comma 1. Boom, here. This is point A. The second point is 2, comma 3. That's in the first quadrant, I guess so. 2, comma 3. 2, comma 3. Here. This is B. And C is the point 3, comma 1. Let me plot that. 3, comma 1 is 3, comma 1 here. This is the point C. Okay, I did that. I plot that. What they want? They want, and the first question is plot each point and format the triangle ABC. Wow. Well, the only thing I need to do is format the triangle ABC. Cool. I formatted the triangle. This is my first job. Plot the point and connecting by the segment line each vertex and format the triangle, no? Okay, I did. It's easy. The second is find the length of each side of the triangle. Oh, so when I need to apply the formula, no? Distance formula, but 3 times. I need to find the distance between A and B segment. I need to find the distance between B and C segment. And I need to find the distance between, what is the next couple game we have? AB, BC, AC segment. Entonces let's do it, pero let's do it fast because you know that. So I know that you open a big square root and you put inside the square root the subtraction, the component is square. For example, in between A and B, you're subtracting the x component, no? Que, ¿cuál es the distance between -2 and +2? The 4, right? The 4. It's all big 4, right? It's all big 4 square. And you're subtracting the y component, 3 minus 1 or 1 minus 3. It doesn't matter the order because when you square become positive, 3 minus 1 is 2, and 2 squared is 4. So 2 squared. Actually, we have 16 plus 4 is 20. And square root 20, I suppose we can simplification a little bit. Oh, no. Yeah, well, let's do it. Why not? I know that 20 is divided by 2, 10, divided by 2, 5. Oh, yeah, it's possible because we have a couple 2. And this couple 2 means we want to fly outside is 2 radical 5. Okay, either way, this answer is more elegant and this answer is perfectly valid. Either way. Okay, do you understand this? This is the distance in between A and B. So that distance. Okay, now let's move in BC. I suppose it's short. BC is in between B and C. And likewise, you're subtracting the component, but separately, subtracting the x, subtracting the y. It doesn't matter the order. Some students say 2 minus 3 is -1, or 3 minus 2 is +1, but it's 1. Because when you become a square, it becomes positive. This is 1 squared plus, and you're subtracting the y component, 3 minus 1 is 2, and 2 squared. Entonces es 1 plus 4 is radical 5. And leave it like that because 5 is prime number, no? Get no simplification anymore. Okay, now let's do it BC. I suppose que BC, AC, sorry. AC is the bigger. It's the bigger. We did that. Now BAC, que AC is the, I suppose que the hypotenuse. I don't know if it's a right triangle, no? And the distance between A and C, you take A and C, subtracting the component. Oh, look at that. It's 3 minus 2 is 5, right? F5 is 3. So time. Look at the, it's obvious, it's easy. Look, you walking from A to C. Here, 1, 2, 3, 4, 5. F5, working from 5 mathematically is 3 minus 2. Double minus become positive, and 3 plus 2 is 5. 5 squared. It's 5 squared. Plus the y component. Wow, look at that. 1 minus 1 is 0. We have no elevation. So A and C have in the same height, the same y. Therefore, there are no differences between the y. Entonces, basically 5 squared 0 is 25, no? 25 and it is 5. Wow, the answer is 5. Okay, I did that. No big deal, professor. This is the same idea of the other example, but now the only complication in this example is 3 points. But the same formula. No? Do you follow me? Everyone follow me?
Yes.
Yeah. Now, one extra or two extra is, what do you think about the same questions? The next question say, verify that the triangle is right triangle or no. Right triangle by definition is a triangle. Look at that, right triangle. So you need to verify si it's right triangle or no. A right triangle look like that. This corner is 90 degrees, and this is A or C, sorry. This is the letter we use. C, doesn't matter. CAB. To verify, the fantastic way to verify if one triangle is right or not. Bueno, using portraiter to identification si es 90 degrees o no. Mathematically, si you verify que C square is equal A square plus B square, this relationship, therefore, is right triangle. Okay? Look at the picture. Do you believe it's right triangle or no? Opinion. Come on, opinion. Yes, no. No, definitely no. Everyone is agree or disagree? This is Elsa, no? Elsa, it's you.
Yes.
Okay. Elsa dice, no. Josué Torres dice, no. Everyone is agree que no? No, definitely no. Okay, but you are wrong. It's yes, the answer. Let me prove. Mathematical and geometrical, both. Look, what is the hypothetical hypotenuse? Hypotenuse. I suppose que it's spelling like that. It's the bigger one, que 5. So this is the hypothesis, hypothetic. Hypothesis. Okay, I need to prove somehow que 5 square, que is a C, should be cleaned up. But I don't know. Square this guy, but this guy is radical 20, no? It's radical 20 square plus radical 5 square. Do you understand the thing I am doing? So you take the bigger, I suppose que hypothetical hypotenuse. And I square, it's so big 25. And I take both extra segment, que I suppose que es the lead, and square each other. Entonces 20 and 5. Wow, 25 equal 25. I get the true statement. Therefore, yes, it is a right triangle. Entonces, bueno, what is the corner que es 90 degrees? Bueno, I suppose que the corner que es 90 degrees is the corner opposite to the hypotenuse, que es this. It's a 90 degree. It's opposite to this segment, que es the hypotenuse. You see now? Do you see now or confusing? Come on. I need communication. I understand. Emily is I understand. Elsa, do you see now?
Yes.
Remember, in geometry, the position is not important. You can rotate if you want to see more clear. The classic, of course, I try to confuse you, no? But the thing I want to illustrate is that it is not important the position. So you take the bigger side and you square. And so you prove somehow that the sum of the other two smaller segment square each other plus is equal to the hypotenuse. It's right. Right. Okay, one more extra question. I need to compute the area. Area is two-dimension quantity. Is the area is the area is a surface, no? Enclosed inside the triangle, no? I need to find this area. What is the formula for the area? What is the classical formula we study in geometry, no? Area for any triangle is 1/2. Area of the triangle is 1/2 multiplication the base multiplication by the height. And who is the base and who is the height? Well, and this is easy. This is supposed to be the base and this is the height. But and this is similar, but remember you rotate, you consider, for example, it doesn't matter what you consider the base of the height. Suppose you consider the base here and the height is this. Basically, this is the multiplication, the two small distance is radical 20, this one, and radical 5. So the area for this example is 1/2 the multiplication radical 20 times radical 5. And radical 20 and radical 5 together is radical 100. 1/2 radical 100. And radical 100 is 10. And 10 divided by 2 is 5. But the area of the triangle is 5. In this case, the units that we are using, maybe centimeter, mile, feet, is a square unit. Okay, because it's surface. The other unit that we compute before, for example, this is a unit. What kind of unit? Linear unit, linear. And linear, you know, degree or exponent is 1, so you omit. It's just centimeter or whatever, feet, mile, meter, okay, linear unit. Any question? Any question? Everything is clear? And the distance, area, midpoint. Okay, so what is the application of this? What is the application? Yes or no? Are you clear? I can erase the board. I want. I can do that? Yes or no?
Yes.
Cool. Okay. What is a fantastic application? One of the fantastic application, well, there are many, but one important is to define a circle. A circle. A circle. What is a circle? Definition. Circle. A circle is another geometric figure. This is circle is a set of the point. So a circular line like that, no? It's a set of the point. Any point. So any point. Oh, nice. This is the point x comma y. The definition is a set of the point such that have the fixed distance for the fixed point as the center. So we have a center. This point is a center. And the center, I don't know why it's representing, it's a point, no? Represent two components, x comma y, but normally it's called h comma k. H comma k means the component of the center. It's important that you, for now, you associate que h is x and k is y. O sea, one fixed point que es called a center and one fixed distance. Let me using another color. Que is called radius. This is the radius. So two pieces of information we need to define a circle. So let me repeat definition. It's a circle is a set of the point x comma y such that r at the fixed distance r, let me call this a shortcut. This is just r, it's a radius. When you talk about r, it's a radius from a fixed point h comma k. Okay, so what is the equation, professor? What is the equation for the circle? Well, the equation is easy. To determine the equation, we apply one more time distance formula. The distance formula is equal to square root x2 minus x1 square plus y2 minus y1 square. So it's big long square root. And you apply this formula in this figure. Okay. What is the distance? Well, the distance is r. The distance is r. And what is the 2 points we need to define? Well, we need one totally arbitrary point. It's x comma y. Okay, maybe it's this, or maybe it's this, or maybe it's this. I call in general x comma y. And the other point is the center. Entonces es x minus h squared. You're subtracting the same component, x, and y, and square each other. Okay, plus y minus k squared. Okay, and that's it. No, we refine a little bit this equation. So you, in order to put it in an elegant way, you eliminate this nasty square root. You square both sides. And let me organize in that way. I know the square power and the square root undo each other. Entonces x minus h squared plus y minus k squared equal r squared. Wow, fantastic. And in closing the box, this formula gets important. What's the name of this formula? Well, the name is, this is the equation of the circle expressed in a standard form. And standard is super important because you see clear like water. Who is located at the center? The center, look in the equation, you look at the equation. The center is located at the point h comma k. And the radius is r, equal r, is this number. Okay? Let's see an example. Why not? Let's see one example, elementary, straightforward example. Suppose I need write the standard form of the equation of the circle with the radius is r is equal 4. And the center is the point 2,84. Oh, look like easy. I know it's easy, however, it's tricky. I want to explain why. It's tricky. So you need to be aware for this situation. Okay, I copy my formula. In general, is x minus h squared plus y minus k squared equal r squared. This is the formula. Standard. Our standard is this specific example. So we need two pieces of information. The piece of information we need is a radius 4. Okay, and the center, que es 2 and -4. Basically, so you write the equation, you determine who is h. It's obvious that h is 2, no? And k is -4. in this specific example. I put intentionally one positive and one negative because you see the effect now. When you write here, x minus 2 is h squared plus y minus, entonces k es negative 4, we have double negative become positive equal r, que es 4 squared 16. Bam! That is my final answer. Entonces, I'm warning you, be careful, because the signs of the formula are completely opposite to the sign of the point. You see, when the point is positive and the formula is negative, and when the point is negative and the formula is positive, no? And this in the right hand side is not radio, it's a square, yeah, the radio. So it's not 4, it's 16. Where come from 16? 16 was 4 square, right? Cool? 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 Everyone follow me?
Yes.
Okay, I want to complicate more this. Look, frequently the life is not happy, and the equation of the circle is given in the problem is non-standard. Suppose this example. Suppose it's given that x squared plus y squared plus 4x minus 6y plus 12 equals 0. Wow, what the hell is that? It's a circle or no? Okay, we have another form to express it. Let's call it general. So we have two. General form is something like that. Look, it's like an x squared plus y squared plus one number that I want to call ax plus by plus c equals 0. And we have a standard. Okay, the nice. The standard is x minus h squared plus y minus k squared equal r squared. And this is nice because I see very well the center is located at the point h comma k, and the radius is r. Now we have two pieces of information. R is r. You only put a square in the equation. Oh, C is given the equation and you need to find the radius. You find the square root of this number. Oh, the center is easy. You take this, get this, and this is that. With the opposite sign, of course. But in this, I am totally lost. I don't know anything. I don't see anything. I don't see radius. I don't see center. This is the case we need to solve in this example. Okay? Just I want to explain. What is the question, Professor? Well, actually, we have two questions. Question number one is express it. The equation gets given, gets general form, convert to standard. This is my first goal. And my second goal, why not do the graph? The graph of that circle. We can put in decimals or by hand. Let's do it by hand and decimals after. It's not important. Either way, the way you prefer, guys. So you feel comfortable by hand. So you feel comfortable in decimals. Oh, we're doing both ways today. Okay, let's do it. Okay, so now I'm moving. Okay, now the solution. I want to copy again. X squared plus y squared plus 4x minus 6y plus 12 equal to 0. This is 6. Okay, entonces, for organize this in a standard form, we apply one thing that you know very well because you using in the test number 1, get the completed square. But the new thing in the completed squares is that you complete the square and the x and the y. Two completed square. But what is the organization? The organization is you copy x squared, you copy the same variable linear, okay, and you put a magic number in that completed square. And you organize likewise in y. Y minus 6y plus another box to complete the square equal sign. Entonces, this 12 you move to the other side and you copy two boxes, que es the boxes que contain the magic number que complete the square. Do you understand this organization?
Yes.
Therefore, I take that 4 que es b divided by 2 and square. 4 divided by 2 is 2 squared 4. Oh, it's a coincidence. Okay, this is 4. Exactly like that. It's a coincidence. But not always happen. You take now 6 divided by 2 and square. I don't care the sign. The sign is not important. You take the absolute value, 6. 6 divided by 2 is 3. And 3 squared is 9. Okay, now the magic number in the y part is 9. In order to keep the equilibrium of the equation, you put 4 and 9, because remember, 4 and 9 is the magic number that you introduce artificially in my equation in order to complete the square. Clear? Now,
Yes.
the beauty part. Factorization, this guy is x plus 2. I confront these two. This 2 is square root 4. And this x is square root x squared. Plus y minus, because the dominant sign is the first 3 squared. Equal, in the right hand side we have 4 and 9 is 13. No? 13, and 13 minus 12 is 1. Boom! And this is my new equation, nice, expressed in standard. And this is equivalent 100% to the original. This and this is the same. I want to prove in Desmos to see the fantastic idea. When you are plugging in this equation, you get the circle. You get the circle, zoom, and when you plug in this equation, you get zoom, the same circle, in the same position, in the same radius, in the same center, in the same everything. Okay, ready. We are ready now to plot, pero plot by hand, after using Desmos, pero by hand. By hand, I need to find my famous rectangular coordinate system. We try, wow, rectangular coordinate system. Okay, cool. So now, Desmos is smart and not too smart. In order to plot this, I need the standard, because in the general I don't see anything. Okay, so now I need to determine the center. Looking the equation standard, I determine the center and determine the radius. Who help me with this? What is the center of this circle? Look in this equation.
2 and minus 3.
Say again?
2 and minus 3.
Same mistake. That is the reason I give intention. Remember, opposite sign means minus 2, 3. Do you understand very well this or no? Yes or no? Every student, the answer for the majority of students say exactly like you. Positive 2 and negative 3. No, it's completely opposite sign. My question is, do you understand why it's opposite sign?
No.
No. Okay, cool. Look, this is my equation. Okay, you memorize. An equation always you write using minus, right? Why? Because this formula comes from for the distant formula, ¿no? Ajá, entonces now, suppose que h es negative 2, like that. Plugging in negative 2. Entonces, x minus 2 square plus y minus, and k is 3 positive. Equal, I have no idea. This is not my problem about the radio now. Entonces, you see que double negative become positive. And here, no, stay negative. And you see that this is exactly the same of this. Do you understand now?
Yes.
So the most important is create mentally a shortcut. Okay, and the point and the equation is different sign. Okay, so now you want to do the graph. Okay, you determine the point because I want to plot that point. Now you see who is h? Who is h? H is negative 2. It's the opposite sign of this. Who is k? K is positive 3. And you create the point using this value, negative 2, 3. Cool? Y plot that. Boom. Negative 2, 3. Here, I plot that. Boom. This is the center of the hour circle. And what about the radio? What is the radio? What is the radio? What is the radio?
1.
1. In this case, there is coincidence because 1 is a magic number, no? So actually, you know, normally the idea is the right-hand side in the formula is the radio square. It's 1, to say 1, you apply square root both sides, and R is 1. Cool. Entonces 1 in any direction. Okay, entonces to plot by hand, this, I recommend that you are doing 4 extra points in any direction. For example, 1 up, 1 down, 1 to the right, and 1 to the left. By curiosity, this point would be minus 2,4. A ver, 1, 2, 3, 4, yeah. This point would be minus 2,2. Yes or no? This point would be negative 1, 3, no? And this point would be minus 3, 3. And this is easy because we have a center. Look at that. And so we're moving up. You increasing the y component. So 3 plus 1 is 4. Well, in this case, 4 is 1 unit because the radius is 1. When you go down, you decreasing. 3 minus 1 is 2. At this point, 2. When you try to find the motion horizontally, when you move into the right, you increasing the x component plus 1. So it's minus 2 plus 1 is negative 1. It's this point, look. And when you move into the left, you decreasing is minus 2 minus 1 is minus 3. Make sense? Do you follow me?
Yes.
Okay. This is the way I want. This is one question in the test. The circle look like the small circle. Radio 1, center at the point. I forgot to say that point is the point minus 2, 3. Everyone follow me? Yes or no?
Yes.
Cool. Now I want to show you in decimals. I bring another example, no? And the review package, of course, we practice more, no? Yes, we go over again to this. Okay, let's doing decimals. Wait a second, Desmos. I want to open a new browser. Okay. And I try to ask for Desmos, new Desmos. And we are doing from scratch for you. Okay, this is my account. Okay, cool. So this is, let me share the screen. Okay, okay, Desmos. Do you see Desmos? Yes or no?
Yes.
Okay. So I doing the original equation gets given. The original equation gets given is, let me use on the keyboard. Decimal gets easy. It's x squared plus y squared plus 4x minus 6y plus 12 equal 0. It's important the equal sign because you put it here like expression. Boom! Look at that. Do you see the circle? Cool.
Yes.
Now that circle, I predict. Well, wait, I put in a standard, no? I put in a standard. But this is the last part I want to show you. I determined using complete square. Determine the center, and the center was at the point, I don't remember, minus 2,3. Open the parentheses, minus 2,3. Boom! Look at that. This is the center and the label for the center. And the other famous point was, let me copy separately another line, or you copy together if you want. No? It doesn't matter. For example, when you move over, the point is minus 2,4. Make sense, right? Minus 2,4. Okay, you want to use in the same color, you click here, hold the mouse, the right click, and you change the color to blue, maybe, no? Blue. Everything in the point is blue. Another possibility, more fantastic, in my opinion, you separate by a comma, and you put the same value, the same, as again, parentheses, negative 2,4, 4, 4. Bam, you see? And you can delete that in the same line. Separate by comma. What are the other points separated by comma? Well, is negative 2, comma, negative 2, gets down. Negative 2, comma, 2 positive. Comma, 2 positive. Okay, I did that. Center, up, upward, downward. Now right, left. Right, left is comma, parenthesis, negative 1, comma, 3. Okay, nice, I like. And apply the same property for this as a label. And separate by comma again. To the left is parenthesis minus 3,3. Minus 3,3. Boom, we have completed pictures of this. Okay. Center, and 4 points is enough to define a circle. Now the last is, well, professor, what about the standard? I don't know, let me write the standard because I don't have idea. The standard was parenthesis x plus 2, no? Plus 2. And close the parenthesis, square. plus parenthesis again y minus 3 y minus 3 close the parenthesis square equal 1, no? Remember that the radius 1. Bam! I put intentionally in another color, I put the standard in purple color and the original is given in red color. And you see the perfect coincidence. You see how flashy? That means this is a fantastic way to prove that this equation and this equation together are equivalent. It's the same equation, of course, expressed in different way, no? One is general, another is standard, but represent the same mathematical thing. Okay, so now I have another example. You help me a little bit to the second example. You help me a little bit with the second example. Okay, after we come back to Desmos, I suppose, no? So now whiteboard. Let me share whiteboard. Okay, whiteboard. Do you see whiteboard?
Yes.
Okay.
Yes.
Do you follow me? Do you understand very well today or no?
Yes.
Okay. Suppose another example. Okay, similar. X squared plus y squared plus 4x plus 6y plus 9 equal to 0. Wow. This is a classical example. Never you see in the test. The equation of the circle expressed in standard. No. I am bad guy. I give you in general. And you need to modification in standard. After you determine the center, you determine this radio, and you are doing the graph, and either way, in the Desmos or in the paper, either way. And say, oh, let's do it today in both way. I don't know. You say, it's up to you. What do you want? Okay, so now what should I do? What should I do? I am lost. Who help me? Complete the square. How you manipulate the equation to complete the square? How?
Quadratic equation.
No.
Sorry. The sorry, Professor.
How we manipulate? What should I do? Well, you tell me in common language. You put the x and the y separately, no? Maybe.
Yes.
X squared plus 4x
Plus 4x.
plus what?
Square. 4 divided by 2 and square.
You put a square first. You don't know the number. You put a square. After we, so, guys, it's important in mathematics. You create algorithm in your mind. Okay, you are doing exactly the same anytime. The only thing that change is the numbers. So you separate x and y. And I know that the objective or the goal of the separation was complete square. Therefore, the complete square will have a magic number. No? Now I finish the x part. I take this guy and the x. This is the guy that contains x part. No? And now I go to the y part. No? So y squared plus 6y plus another box. And what about this 9? One of these 9 do not participate in the game. You put in the right hand side minus 2 boxes in order to keep the equilibrium of the equation. Do you understand very well this organization? This is the way I want that you set out in your own test, right? And now, Elsa, the part you try now is you find the magic number. What is the magic number in the first box? What is this guy? Bam. What is this? 4. It's obviously 4. Where come from this 4? Come from 4 divided by 2 squared. Correct? Everyone follow me? Or
Yes.
I need to I need to do here in one corner of the piece of paper or no?
No.
No. And what about the second? The second. What about the second number?
9.
9. What comes from 9? 6 divided by 2 is 3. 3 squared is 9. Cool. That's 9. Likewise, you put this artificial number 4 and 9 and the right hand side in order to keep the equilibrium. Now, crucial moment, factorization. Factorization this. And factorization this trinomial. Okay, by the way, these trinomials are perfect square. That was the intention, no? And the factorization is x plus 2 squared. And the factorization here is y plus 3 squared. And the right hand side, the 9 is cancelled, stay 4. Do you follow me? Okay, Emily. Now, who helped me with the center and who helped me with the radius? What is the center? Let's look at the point, at the point, at the point, at the point. What is the point, the point, the point? Guess user. Who is guess user?
-2. -2.
-2, comma?
-3.
Excellent. Be careful because I am bad guy, remember. Intentionally in the test, I put confusing signs, but you need to be. And what about radio? Radio 4. Michael Lopez say radio 4. Are you agree or disagree with the Michael Lopez?
Disagree.
Disagree totally. Oh, why? What is the radio then?
2.
2 is a radio. Because Marco, look. You compare this equation and this equation. X minus h square plus y minus k square equal r square. Entonces I realize the r square is 4. Therefore, square root both sides, r alone is 2. Okay, that is the reason here again. Okay, square root 4. Okay. Okay, so we have the piece of information. Okay, we need to do this. We have. Okay. Wow. I don't like this. Okay, it's maybe much better rectangular. Okay, so now, what do you recommend me? Now, do the graphic and using in Desmo or in paper? No, actually, well, no. In the test, I provide you a rectangular coordinate system for doing by hand. However, I don't care. I don't care because you are doing Desmo and you want, you take the screenshot and you copy and paste inside the test. It is for me the same. So what do you consider much better? Doing both way or using Desmo only or in paper?
Both way.
Both way, okay. For both way, I need a rectangular coordinate systems. Image. That one. Let me enlarge to see more clear. Okay, I plot the center. Okay, the center, remember, was the point. Let me, okay, a little bit. Okay, the center was. Okay, much better like that. This is the only information they need. -2, -3. -2, -3. Bam, like that. -2, -3. Here is this point. Cool. Cool. Now, remember, I need to do by hand 4 points. In what direction? Over, downward, right, and left. So it's like a north, south, east, and west. And the 4 important directions. And what is the distance? Well, the distance is the radio. is the radio, and the radio is 2. So it's 2 point over, we get that point. 1, 2, 2 point downward, 1, 2, 2 point to the right, 1, 2. Oh, this is on the y-axis, nice. And 1, 2, this is this. Okay, well, for me it's important. You write the point. This point is center is this. This point is -2, -1. Okay, because it's -1, yeah. Because basically the thing is the point center is -2, -3, but when you move in vertical, you affect only the y component, no? Es -3 plus 2, que es el radio, plus 2, que es el radio, es -1. When you move it now downward, down, this point would be -2, so the x component doesn't affect, but now it's -5. Where come from -5? Well, -5 is -3 and -2 is -5. Now, when you move into the right, you affect now the x component. So -2 plus 2 is 0. Okay, it's logical because lie on the y-axis. Any point on the y-axis is 0, something -3. So the y component stays the same. They only affect the x component. The y component no. And this point is the point -4, no? -4, -3. So one more time, the y component stay the same. Remember, that point was -2, -3. This is the most important. I forgot to write. This is the center. And when you're moving to the left, you're subtracting 2, get the radio and the x component. -2, -2 is -4. And now ready to do the graph of the circle. Wow, no good. My graph by hand is no good. Do you follow me?
Yes.
Super clear. Super clear. Let's do it in Desmos. Come on, together. Sophia, open in your computer. Open Desmos also, please. Let's try. Okay, there you go. I want to explain something for you. Okay. Sorry. Share the screen. Okay, everyone working with me in Desmos. Well, no. You're working after you watching the video. Because well, you can have. No. Okay. This is the Desmos. Do you see Desmos? Yes or no? Yes or no?
No.
No.
No. Okay. Let me try again. Share Desmos. Do you see or no? No.
No.
My computer indicated you should be. You should be able to see. But okay, sometimes doesn't work very well. I need to share again. Now. You see or no?
No.
No.
No, nothing.
What do you see? My face?
Everything is black.
Black.
Yes, same for me. Everything is black.
Okay. Let me try one more time. Stop sharing. Share screen. Desmos. Now?
Yes.
Google,
Yes.
it's unbelievable. Okay, let me explain one more thing in the manipulation of the decimal, and we solve this. Look, pay attention, please. You press this plus sign, and this plus sign allows us to create something, create folder, table. But folder is important for me now. I put in the folder one specific name. For example, example one. It was the example that we are doing before. Example one. And this is the folder. And you can move in any place here, the folder. Not necessary to move. You introduce each equation inside the folder. And you see magically how one think gray line now is connected with the folder on this. And we can click in the arrow and you see how condensing or expand the information in the way you want. You see que fantastic.
Yes.
Do you follow me? Not necessary to do now, only understand. Now, likewise, we are doing in the example 2. You click in the plus, you create new folder. I want to call example 2. You press enter, and you one by one you put equations. Let's do the equation for example 2 that was, remember, x squared plus y squared plus 4x plus 6y plus 9 equals 0. No double zero, only 1 0. Okay, there you go. Wow, look at that. This is a circle. And we plot the famous point. Famous point was the center first, negative 2 comma negative 3. Negative 2 comma negative 3. Look at that. And the corresponding label. Wow. The label you can remove if you want. No? I don't know. I like that. Comma. The 4 famous point in the 4 important direction. North, south, east, west. Okay, north was negative 2 comma no, I using the carajo. Okay, delete that part. Okay, and negative 2 using the keyboard, much better. Not my own keyboards, the keyboard of decimals. Comma, negative 1. Cool. Separated by a comma, any point, open the parentheses, using the keyboard, specific keyboard of decimals is better. Then the second point down is minus 2 comma negative 5. Minus 2 comma minus 5. Excellent. Okay, let's move on to the next point. To the right is 0 comma minus 3. Whoa. Parentheses 0 comma minus 3. And to the left. And to the left is open parentheses negative 4 comma minus 3. Okay, super. Now the confirmation that we're doing well is write the equation that we found in standard to verify que it's a perfect coincidence with the original. And the equation that we found was parentheses x plus 2. Square plus parenthesis, y plus 3, x squared again, equal, and this radio, remember, was 2, but 2 squared 4. And you see I put in green color, and the perfect coincidence between the green color that was the standard and the general que this. So they basically, the thing that we are doing is algebra. And the algebra, you know, modify, it's not new for you to understand this. You have equation and you solve the equation, you modify a little bit. In this case, we apply the technique of the completed square. Okay? Do you follow me? Okay, and the rest of the time, can we have, let's do one more example, because I don't want to start new chapter. New chapter, no, new topic inside the chapter 2. One more example, one more example, one more example, one more example. A little bit tricky, a little bit confusing. Okay, let me know if I switch it or not to the whiteboard. Switching to the whiteboard. Do you see my whiteboard or no?
Yes.
Okay,
Yes.
I like your yes. Yes. Who are you who say yes? Okay, suppose example 3. Example 3 is 3x squared. Wow. Plus 3y squared. I never see that before. Minus 12x minus 24y plus 12 equals 0. So I never see before when you have coefficient c. So normally in my mind, x squared plus y squared plus ax plus by plus c equals 0 is the general part of the equation. But no, we have no coefficient. Oh yeah, we have one coefficient, not 3. But in this case, it's the same because the most important is that this coefficient should be equal to this coefficient. If you divide the entire equation by 3, so you take the entire equation and division, divide by 3, 1 by 1, divided by 3, 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 also in the right hand side divided by 3, no, in order to keep the equilibrium. In this case, it's nice because any number is divisible by 3. But don't expect that this situation happen. In this case, happen, but it's nice example. It's x squared plus y squared minus 4x minus ay plus 4 equals 0. Because 0 divided by 3 is 0. Okay. You have a nice equation with a small number and coefficients here is 1 and 1. Okay. Now remember the organization of the completed square. The organization for the completed square was, you copy the x and y separately. X squared minus 4x plus box plus y squared minus ay plus another box is equal to -4 plus 2 boxes. Everyone follow me?
Yes.
I need help. What is the first magic number?
4.
4. F4. You're right. And remember that 4, when you put artificial this 4, you put another 4 here. Okay? And what about the second?
16.
16. Very well. Welcome from 16. 8 divided by 2 is 4, and 4 squared is 16. Everyone follow me? Or I need extra explanation? Everyone follow me? Who helped
Yes.
me? Who helped me factorization the first trinomial, the first one? What is the factorization this guy? Okay, by the way, it's perfect square. Si it's perfect square, the factorization is only one parenthesis square, right?
X
Yes.
minus 2.
X minus 2, very well. And what about the second?
X minus 4.
Y minus 4, correct. In the right hand side, nice. This is cancel out and 16. Wow, I have my new equation standard. Now I can determine super easy, super easy, super easy. Who is the center? Who is located center, 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 and radius. And radius. Where is located the center? At the point, help me.
2 and 4.
2 and 4. Positive both?
Yes.
And what about radius?
4.
4. Que es square root 16. Super. It's doing the now the next. Okay. This typical question in the test. By the way, is the last question. The test contains, similar to the test number 1, 12 questions. I don't remember if it's 12 or 16. The last question is one problem similar to this. You apply, complete the square, you determine the center and radius, and just a lot of people make a mistake in that part because believe get the same sign, no opposite sign. Okay, entonces now 0 for you. Now the final answer que they want is do the graph. Okay, do the graph. Do the graph. Okay, the center was 2, 4. 2, 4. Here, over there. This is the center. And the radius is 4. Oh, it's too long. 4 in any direction. 4 over would be 8, no? Because 4 plus 4, look, 4 plus 4, so the north point is the point 2, no? But okay, don't worry. We are doing our best. I have a rule. Extending a little bit, 90 degrees, this axis. Okay, extending a little bit this axis. Yeah, I believe A is 7, 8, approximately here, right? I don't know exactly here. This point is the point, 2,8. Okay, the south is down, would be 2,0. Why? I don't understand. Because the radius 4, and you're subtracting 4 because I go down. When you go down, subtraction who? Subtracting k get 4 minus radius is 0. It's 0, it's here. 2,0. Okay. I suppose, using my intuition, A is a little bit because it's the same distance, no? A little bit here. Okay, cool. Now the east is to the right, and to the right is 6,4. Where come from this 6? Bueno, es 2 plus 4. And the k component stays the same because the motion is horizontal. Entonces es 6,4. I suppose que es this point. And the west is to the left. And to the left is negative 2,4. Oh, look, the important is when you move it horizontal, the y component stays the same, but the x component change. It may be positive or may be negative. In this case, 2 minus 4, 2 minus 4, 2 minus 4, and negative 2, is exactly this negative 2. So negative 2 comma 4, let me see, boom, that point, negative 2 comma 4. Now we are ready to do, you know, roughly, very, very roughly, our circle. Look like that. Oh, no good. Oh, no good. Oh, no good. Approximately like that. Okay. The important is to try to do your best doing the circle. And the pencil is easy. I have a electronic pen here, so it's not too easy to manipulate with me. No? Okay. Now let's do it in Desmos. So you see Desmos. Let me try. Do you follow me? Everything is clear? No? Let me switch into Desmos. Now, do you see Desmos? No.
Yes.
Oh, the switching was fantastic now. Remember, example 3. Yes, are all clear so far. Okay, so now I create a new folder. The name of this new folder is example 3. I type in my own keyboard. You can, if you want, click, hold the mouse, the left click and the mouse, and drag. And you put in order 1, 2, 3, 4, 5, 6, 7. And you press enter, down, and you copy. You copy everything you need. I copied, of course, not the ugly original. I copied the new one, que es x squared plus y squared minus 4x minus ay plus 4 equal to 0. And this is my circle. And that's my fantastic, because when you are doing any curve, you see an important point, is the x in a set and the y in a set in gray color. It's not important now. It's important this, and it's important this. And this is the y in a set. This is another y in a set. We can find, but no, it's not important. Okay, the important point for me is, in parentheses, the center, of course, 2,4. Black color. I like black color. Another point is separate by comma, 2,8. Look. Another point is separate by comma, 2,0. I did north and south. Now east separated by comma, 6,4. I forgot the parentheses. Sorry. 6,4. Excellent. And minus 2,4. Excellent. This is my circle, my famous 5 point, 7 and 4 point in any direction, any important. Now to verify that we are doing okay or no, I put a equation that we obtained when you expressing a standard. It was my friend. It helped me to understand much better this, because I don't have idea where it's located center, where the radius. You know, after when you transform it to a standard, you see everything clear. Open the parenthesis, x minus 2. Okay, a square. Look, esa parábola plus Open another parenthesis for the y part, y minus 3, minus 4, sorry, minus 4 square equal 60. Is the radius square. Oh, double equal. I put double equal. I am crazy. No, only one. Oh, and red color. And you see the perfect coincidence between the purple color equation and the red. So that means they are algebraically equivalent and geometrical equivalent, both. Super cool. Do you like that? I love that. Cool. Okay, so now you close if you want and you save. Okay, suppose you are doing, you save here and you put a title. The title is circles. Example of circles. And you press save and you have in your cloud if you create account. Look, I create account. The account have my name. The only information that you need is the username and password you create. Sorry, no username. Email account and password. We are using everyday decimals. Sometimes in the complicated scenarios, I provide the script, but you need to will be able to create your own script. Okay, if you like, no. Either way, this is totally optional. And your test, any graph you are doing using decimals. Okay, guys, cool. Very good.
Yes.
Okay, so bye bye. I'm leaving because I have another class now.
Bye. Have a good day.